Okay, for today, it's complex numbers, third day of it, and we're going to be doing another form of complex numbers, which is polar complex. The questions are going to start looking like 4 cis 5. Anyway, right now I want to remind you before we delve into the new stuff about how to long divide, because one of the toughest things on this test is we'll tell you something like, oh, 2 is, or actually I said negative 2. Negative 2 is a root. You got to be able to say if negative 2 was the root, then x plus 2 is the factor, and then you have to be able to factor this thing out. Okay, so long division on this. I had kids work on this before I started the video, so hopefully they've already had a chance to do the long division problem. This would be x squared up here, because x squared times the x will make x to the third, and that'll make that cancel, which is awesome. These two will like subtract off in a minute. All right, so I'm going to finish it. That times that plus 2x squared. Draw a line. This is important because it's not always just subtracting them and making them cancel. Sometimes there was a negative number here that needs to change to positive. So you're just changing the signs to the opposite of whatever their signs were. Okay, so now I have this does cancel and this does cancel because they are opposites of each other. When I add that and that, they disappear. So these are all gone, which is awesome. I get a 0, and then I have to bring down more stuff. Always bring down, you have to have 2 things to work with. If you have 2 things here, you'll need 2 things to work with. Okay, and then you should have said x squared, and then, okay, how can I get this to match up? A minus 6 right here. Minus 6 times the x will make minus 6x. Awesome. Negative 6 times negative, or positive 2 makes negative 12. And remember me saying before that you always change them to the opposite signs? So we aren't always just subtracting there. Okay, you change them to the opposite signs. Now we can put them together. These do cancel, but these don't cancel. Did I just copy it down wrong? Okay, thank you. If, just so you know, if you had come up with an answer of like 10 down here, do you get that your answer would have been there, that this was not a root? I said it was a root, but it actually wasn't. Well, we won't do that to you on the test. If we say it's a root and you don't get a 0 at the end, it means it's kind of nice. It means somewhere in the process you screwed up, and at least you know you screwed up. You get to go back and try to find where your mistake was. All right. My mistake was just not putting that as a 12. Oops. And now it does cancel, and it's a 0, which is good because that means it actually worked. And when I'm saying it worked, what does that mean? I have factored it. That times that makes all of that. Okay, so with really the goal was to factor. And I got it factored. I knew this was going to be here because they told me negative 2 was a root. And then the other part is x squared minus 6. Okay. Now, could you factor it the rest of the way? Some of you are like, but I already factored it all the way. No, you didn't. This can be factored further. Taught you a little trick on that the other day. And I know you're thinking, but you said when it was plus. Okay, but that doesn't mean it can't work when it's subtract. You already knew how to factor these before, but we always just happen to use really nice numbers. I want to show you what I mean. X squared minus 25, and then you'd go, oh, x plus 5 and x minus 5. Yeah, because we gave you a really nice number, 25. What if we'd have given you 21? Doesn't have a nice square root. You still could have done it. Get what I'm saying? It's just the square root of 25 goes here and here. So x and plus and a minus and what? Square root of 6. Do I need an I in this case? Nope. If you multiply out what I just had, I do first outside, inside, last, this will equal this. So there, that's factored all the way. Why didn't we do that before? Well, because now we're open to answers that are irrational, like square root of 6, and answers that have I in them. So imaginary and irrational answers are okay now. In the old days, we'd just say, oh, there's no real answers. In fact, usually you guys just said there's no answers. And I usually would correct you and say there's no real answers. Because coming to this day, there are answers. Okay, so Let me do one more like that. This is a review of yesterday, but so important so that you, it's one of the secrets to kids doing well on these tests, in my opinion, is you got to practice it. If I just show you once and then I expect you to like do it, perform well on the test, that's going to be really tough. So I make you review it and practice it. So let's do one more like that, except this time I'm going to tell you that, for instance, if I just said I is a I is a root, you should instantly know two factors. Did you just put that together in your head now? If I say I is a root, that means you know two factors of the thing I'm about to write. I'm going to pause while you figure that out. If I is a root, you should know two factors. Okay, did you figure out if, since I is a root, do you remember me saying you always start with x minus and x minus? Okay, so if I is a root, boom. But remember how they always come in packages of 2? And if I is a root, then what do you also know is a root? Negative I has to also be a root. So I'm going to put negative I right there. Don't try to do this some other way. I'm telling you, you got to start with x minus and x minus. It really, really, really helps. Because then whatever the root is, you can just slap it right here. Because later the roots are going to get complicated. Like I'm going to say a root was 2 plus 5i. And you have to know, okay, x minus 2 plus 5i would go there. All right, anyway. So trust me on this process. Now, that meant x minus I, and x minus minus means plus I. And then that means if I multiply it all the way out, x squared, outside, inside cancel, and then I have minus I squared, which means plus 1. Why did I do that? Because now you can put that here. You can long divide with that. All right? So here's what I want you to long divide with that. This is going to get a little weird because there's going to be a missing term. Now, some of you that are like super concrete sequential, and if things don't line up, you go crazy. You might want to put in a plus 0x in there. You can. You don't have to. But if you notice that there's a missing term like that, you can put in a plus 0x if you want to. Yeah, I don't require that though. So, hint, we want to start with something up. Oh, and I screwed up something. Sorry. That's next to the third right there. Sorry about that. I just was going too fast. X to the third minus 4x squared plus x minus 4. Okay. So, you put an x up here and go from there. I'm going to pause for a second while you try to finish that. Okay. I know some of you are not done. I need to get started though because it's kind of long. And so you keep working if you want to finish it off. If you want to, every now and then look up and see what I did. X times x squared made x to the third. X times the 1 made plus an x. But if I put the plus x right here, it's not going to line up very nice. See what I mean? Because then I can be trying to add an x to an x squared, and these aren't like terms of each other. That's where that whole, like, if you had added a 0x here, it might have been nice, but I can just flow with it. I'm going to say, okay, I have to have an x somewhere. I guess I'll put it right underneath this other x. And then I draw my line. And then I have to do opposite of, opposite. And then my x to the thirds will cancel, just like normal. That, there's nothing here. If I'm adding nothing to it, it just comes down. This part cancels, it's gone. And I have just minus 4 left. Remember, you always need 2 parts down here to work with the 2 parts that are up here. All right, now what do I need? I need a minus 4. So that the minus 4 times the x squared will make minus 4x squared. And the minus 4 times the 1 will make minus 4. And now everything's back hunky-dory again. So there's just that one moment where things didn't line up nice. If you can roll with that, then no big deal. Cool. I just figured it out. X minus 4 and x squared plus 1. And I go and write that on my test. And Mr. Server cries a little bit and marks it wrong. Why? Because it's so close. They just had to do one more little thing. You haven't factored it all the way. You haven't factored it across the complex numbers. That is x plus and x minus what? I. There. That's your goal, is to factor it all the way across the complex numbers. Okay, now we got to get to the new stuff. So, the new stuff is where we have a whole nother kind of graphing, but the nice part is, at least, it's very, very similar to polar. There's something called rectangular complex form, and then there's something called polar complex form. Now, I know it sounds really, really scary, but it's really not that bad. All right, first of all, we got to go over what a complex number is again. It's got a real component and it's got an imaginary component. Let's say it was 1 plus 3i. How are you supposed to graph that? It's imaginary, for Pete's sakes. So, mathematicians made up a way that you could graph this. They said, how about if we just use x and y again, except the y will be the I direction. So we call it yi, xyi. But now, it's as simple as you might think. We go over 1 in the x direction, because this is the real part, and this is the imaginary part, right? So this is the real part, and this is the imaginary part. So what's the real part of this number? It goes over 1. There, I went over 1. And now I'm going to go up 3 in the imaginary distance. Do you get if I put a dot right there? I am saying it's got 1 real and 3 imaginaries. It's kind of like 1, 3. Does that make sense? If you think you understood that, would you just try to graph this for me? -2, comma, no, not comma, sorry, plus 4i. Try to figure out where -2, 4i should be. This is rectangular because it's got an x and y part, but it's for a complex number, so it's called rectangular complex. Did you get that to get this point graphed, I go 2 to the left, and then I go, I'm going to make those marks big enough. Give me a second here. There we go, 2 to the left, and then I go positive 4i, go up 4i, and I put a dot there. Unfortunately, it's kind of right about where that should be, so I put my dot right about there. That's this spot. Raise your hand if you had that one right. That's all there is to it. There, you've learned rectangular. Rectangular what? Complex, or complex rectangular. That's a way to graph a complex number. Okay. Now, for this next kind, we're going to make complex numbers get graphed in polar. All right, so first, let's do a simple one. Let's start with rectangular, actually. Get yourself a new graph. You don't want to have too many dots on one graph, okay? And this is the x and this is the yi distance. Okay? And let's do 1 plus I. A nice, simple one. Would you please just graph that in rectangular? Rectangular what? Well, there's an imaginary number involved, so complex rectangular. So you go over 1, and you go up 1, and you put a dot there, and that's all there is to it. It's a dot, right? It's not like a line and a dot. It's just a dot. Just a place. Okay, so that's just to review the other one. Then who has a theory about what's going to be involved when I change it to polar? How about this? Do you even remember what polar is? I'm going to go off to the side and say, just for a second, would you graph this spot? 3 comma pi over 6. Just graph something in polar, just to remember what polar even is. Give me a simple graph of the polar point 3 comma pi over 6. That's in r theta form. SR S theta. So you go up, that's pi over 6 again. How many degrees? 30 degrees. So you go up 30 degrees, and then you go out, how far? The radius of, in this case, 3. That's a spot that's in polar, just simple polar. Did you see any I's involved? Was there an I anywhere? No, so that was not complex polar. That was just regular polar. So now let's try to put the pieces together. If I wanted something like this, but I wanted it to be graphed like a polar, then do you get, I would need to know the radius here. You know what I'm saying? And I need to know the angle here. Do you get why I picked the point 1 comma 1? Because now I know what the angle is. Do you? I need this to be in polar, so I need an r and a theta. It's just a special kind of polar. It's polar for imaginaries. Complex polar. So I need an r. By now, I hope you've made a little triangle. You can figure out that we're making a triangle here. And this is 1, and this is 1. Didn't put that together, maybe you were confused, but now I hope you're like, oh, I recognize this, 1, 1 root 2. I know that triangle. I know what that angle is. What angle is it? 45, we never say 45, though. We actually use a different format. Pi over what? Pi over 4. So this angle right here is pi over 4, so it's pi over 4. And then what was my radius? Root 2. That is a polar graph of an imaginary number. The only thing that's really different is we have an I right there. And our original problem had an I right there. Now you might be saying, wait a minute, Mr. Server, shouldn't this be I right here? Shouldn't this be an I? Nope. It's the number in front of the I. There just happens to be a 1 in front of that I. And so this is not an I. You don't ever label things as like a distance of I. Think about it. You can't have an imaginary distance. But this is how many I's you had. All right? Okay. Last thing is, now that it's written this way, we can write this thing called cis form. You might be thinking, this is getting so intense. Nobody would ever ask me this kind of a question. I will never see this again in my life. There was a cis form question on the last ACT test. The thing I'm about to show you was on the last ACT. It wouldn't, it could, I don't even know, because I didn't see it, just kind of heard, saw on the internet, people were talking about how there was, holy crap, there was polar cis form on the last ACT test. So this is not that intense, because the ACT is supposed to not go through calculus. Well, hey, it does go through pre-calc, and you're in pre-calc. But cis form wasn't even talked about in regular pre-calc. All right, so how do I write this in cis form? It's really simple. Root 2 cis pi over 4. Now, see if you can like make the extension then. What would it mean then if I asked you to graph 3 cis pi over 2. Remember, these are dots. They're not triangles. Triangles help us find the dots, but it's just a dot somewhere. Three cis pi over 2, where would that be? I'll pause for a second. If I were you, I'd make a new little picture. Put a dot where you think 3 cis pi over 2 is. Pause for a second. Okay. I wouldn't start with the radius of 3, because it's hard to know where to draw it. You got to draw something that's 3 long, but in what direction? I'd start with the pi over 2. Pi over 2 is going in this direction. And then how far should that go? 3. So then I say that that's 3. And there it is that dot right there. Now, one more thing. I need labels on my x and y axis. You know why? Otherwise, if this was just normal x and y, you have just graphed the point 0, 3, and that is not correct. If you're in the right system, this is x, y, I, then you should know that 3 cis pi over 2 equates to, well, that was polar, but we can still get rectangular from it. Do you get this is kind of like 0, 3? But it's not the normal point 0, 3 because it involves imaginaries. So what's the rectangular coordinates for it? What is this written in rectangular form? 0 of the real part. Remember, you might want to even put real here and imag here. Just to remind yourself, you have 0 reals and 3 of the imaginary. Do you get this was really 0 plus 3i? I just converted 3 cis pi over 2 and tried to show you how it was 0 plus 3i. Let's see if you can do another one like that. 5 cis negative pi over 2. Will they know where to go? I hope so. I'd start by graphing it, figure out where it is, and then you'll be able to say, oh, so you've got 7 plus 4i, or whatever it equates to in rectangular form. Hint, graph it first. I'm going to pause for a second. Okay, so here's how I graph it. Again, some teachers actually teach it this way. They say go out 5, but then move it to the right place. I don't really like that. I'd rather figure out where the right place is first and then go out 5. Remember, negative pi over 2 is actually down there. And how far should I go out? 5. And then there's a dot right there. Raise your hand if you put yours in the right spot. Then, what does this mean as like a what plus what? This is supposed to be a complex number. It's just in a different form. It was supposed to be, how much real did it have? 0 plus how much imaginary did it have? Careful on this. Can it be negative? Have you ever seen minus 5i, for example? Yeah, you have. You've seen negatives there. So it's okay that this is in the downward direction. So therefore, this is minus 5i. Now, I could say just plus minus, of course, could simplify to 0 minus 5i, but either of those two would have been good answers. Raise your hand if you had that. Okay, so now can you go the other way? What if I start with 4 plus 2i? Can you figure out what the polar version of this would be? Polar complex. Hint, go with the graphs. Graph where that is. And when you don't know the sides on one, which I don't think you know these sides, it's going to make a triangle you don't know. You use inverse sign to tell the angle. So start by drawing the triangle. Realize, okay, I know all the sides. You'll know that. I don't know what these angles are. Use inverse. actually inverse. Is that inverse sine or tan? I'm going to look that up. Oh, yep, it's inverse tangent that we would use to give our angle at the end. All right, I'm going to pause. We give this a shot. X, Y, I. Real, imagine. Where's over 4 and up to? Dot. Remember, it's a dot that we're graphing. It's not a triangle. Now, I have triangles kind of helps me to figure out the polar version of this. All right, to write this in polar, I need an r and a theta. All right? So, what's my r, my radius, that number? Well, you can do this, even though it's not one that's nice. 4, 2, and then this is always square root of, and this squared and this squared. So it's 16 and 4 makes 20, square root of 20. Raise your hand if you had square root of 20. Awesome. Then my r is root 20. Then my theta, my angle, I don't know what angle that is. I don't have this triangle, the 2, 4, root 20 triangle memorized. So I use, these two are nice clean numbers, right? I could use those in an inverse tan to say the angle. That angle would be comma inverse tan opposite over adjacent 2/4, also known as, if I reduce it, 1/2. Woo! Serious math. Not only are they imaginary numbers, you're graphing them in polar. All right. Tricky stuff. So, typical questions. Let's actually look at your homework. I'm going to pause for a second. We'll hold that up for a second. I just want to remind you for a second that we are going to use these two quadrants, and that we need to remember that when we're doing this kind of graphing, you could have in the old days said this was 3 pi over 2. But we are going to be using inverses in our answers a lot of times. And if in inverse trig, we would call this negative pi over 2. You are going to be using that as negative pi over 2. This, of course, is still pi over 2. All right, moving on. Here we are, day 3. It asks you to find a polar representation for the complex number. And then we ask you to just do this. So you actually can cross all that off. All we really need is r and theta. All those other things we're asking you were things like this. What's the real part? 9. What's the imaginary part? 9i. Okay. But what we really care about is r and theta. So in other words, if you know where this is, if you can find that spot, then you'll be able to tell me r and theta. You know, for polar, we'd need r and theta. Okay, so this is x, also known as the real. You don't have to write that every time, but I would put the x and the yi for sure. Because if you don't put yi on your axis, you haven't really graphed it in imaginary numbers. Okay, then I'm going to go over 9 and up 9. I put a dot. And then, of course, that kind of brings an implied triangle in of 9 and 9. And, ooh, I know that one. Even though it's not the common numbers, if those two are the same, it had to be a 45-degree angle, didn't it? So if that's a 45-degree angle, I know my theta. What's my radius? Well, that's not quite as easy. Square root of, and 9 squared is 81, and 9 squared is 81, and 81 plus 81, we're square root of 162. Did I get that right? Okay. 180. 80 and 80 is 160, and 1 and 1 is 2. 162. You take 9 squared and 9 squared, and then the square root of both of those added together. Could you just use a squared plus b squared equals c squared? Sure, if you want to, but you're going to get the same answer, square root of 162. Okay, now r, that, theta. If you had left this as the inverse tan of 9 and 9, it wouldn't be simplified all the way, because you know this one. Because the sides are a ratio you know, you should be able to say, oh, that's a 45. So therefore, r was square root of 162, and theta was the angle, and that's 45, also known as pi over 4. Cool. Done. All right. So which ones are we doing? You notice that there are certain ones that are circled here. We're going to do the ones that are circled. So I did the first one for you. You're going to do number 2 and number 9. Moving into this area, we're going to do number 17 and number 19, all the ones that are circled here. All this is going in negative directions. Not super complicated. Then they give some in cis form. Don't freak out. Remember, if it's 2 cis pi over 6, that's the r, that's the theta. It's just like they said 2 comma pi over 6. You just have to use the y-I axis because these are imaginary numbers. I'm going to tell you later about what the CIS stands for, but we didn't have time for that today. So it stands for cosine I sine, but you'll find out later what that really means. Okay, so when they're in cis form, all they're really doing is saying, here's your r, here's your theta, just in a different format. Okay? So when we're done with something like this, your answer will be like, I'm not saying this is the right answer, but your answer would be like 2 plus 5i. You're trying to find it in the other form. This is rectangular form, where it's kind of just got its x and y. And this is cis form, which is also a polar form. All right, so I'm just going these 3 problems on this page, and then we're done. Stop right there after you've done 3 that have a cis in them. It's a little bit bigger homework than normal, but this is tough stuff. You need to practice it a little bit. I want to be a couple of each kind. That's all I'm going for there. Okay, that's all I got for you for today.